All right, good morning, everyone. My name's Steve DeMetrick. I'm a builder here in South Kingstown. I've been building for about 25 years now. We built the first certified passive house in Rhode Island, which is like just up the street here about, it's been like 8 years ago maybe. And since I built that house, I used to build just regular code-built houses. And I started learning about efficiency, and actually I became BPI certified like in 2010. And started learning about air sealing and just learning what to do better. And then I discovered Passive House, built that house, and now all we build are either certified Passive House or we go through the Energy Star program with a clear result, and all of our houses will get built to the Department of Energy Zero Ready Home program, which is actually 95% of the way to Passive House. So we've been doing that basically since that first house. Yeah, actually, I just talked about what we did. Yeah, that's us right here. And this morning, actually, there's a lot to this, and like a lot of the questions that came up that John was like, oh, we can't talk about that now. I've been studying this been building this stuff for 15 years, and I'm still learning, so there's no way we're gonna get through that with a couple of Q&As back and forth. So just be patient. This is a long learning curve for everybody here. And I'm teaching this, and I'm still learning. So hopefully my goal is to share the bits and pieces that I've learned and try to communicate in a way to help you get there faster than it took me to get there. And as always, if there's questions, I love this cartoon. Hopefully somebody gets it someday. I got enough reaction to that, but yes, I'm talking about cows. So what is air sealing? And I'm specifically, I've done a lot of these presentations, and I'll go through an entire house, and like the house that John was describing, yeah, it's a 90% reduction, and it's great, and we did that. I don't know, it's a custom home, but it's an entry-level custom home. Like if you went to a custom home builder down in South County, they're gonna start at $400 a square foot. We designed and built that house for about $275 a square foot. You know, it's not a spec house, but we designed and engineered the house just through our material choices and the size of the house and the shape, and then we actually put all of that energy efficiency metrics and engineering into that house, and we actually made it less expensive to build by following those passive house principles. So everyone thinks that it costs more because they're taking a normal house and then adding all this technology to it. We're starting with the technology and building our house around that. And when you go that path, you can actually get there cheaper. And an interesting metric that most people don't realize, but like when you get into large scale commercial and large multifamily homes, there's probably thousands of case studies already out there and documented that show that it's actually more cost effective to build a passive house certified 300 unit affordable apartment building than to build it to code. Thousands of case studies out there like that. So I'm specifically going to talk about just air sealing, like how do we get there? So if we have to meet this new code to get to 3 air changes per hour, the systems I'm showing you here that we use in our houses, we're constantly getting to like 0.2, 0.3, like just really, really low numbers. So this is the basic concept of air sealing, is there's holes in our houses. There's a little metric here, like we know all this stuff, like you've got chimneys and fireplaces, you've got like holes through like you get staircase, I've been in houses with elevator shafts, light fixtures in the ceiling, you get leaks down at sorry, I got a red thing here. Where's that? Oh, there we go. Yeah, we've got leaks at the foundation, we got leaks at the framing, we got leaks at windows. So we're basically, they're holes in a bucket, and like, how do we close them? And one of the things here is also, we look at the holes in the bucket, the forces on that bucket is gravity. So if you put your finger over one hole, then it's still gonna come out of the other hole, because that force is not stopping until that bucket's empty. So with air sealing, we're basically looking at what forces are pushing that air out, where are the holes, the forces aren't gonna disappear, but how can we control them? Like how do we put our fingers simultaneously on all the holes in that bucket? And these are the forces that we're talking about in our houses. Should I miss one? Yeah, this is the major one that people talk about is stack effect. And stack effect is basically the air inside the house we're trying to control it at a certain temperature. So this is winter time. The air inside this house, let's say it's 70 degrees and it's 30 degrees outside, that warm air is more buoyant, it's gonna move up. And as it moves up, it finds all these holes in the house. Like this could be an air leak in a wall, like say an outlet box, has a wire that goes in, goes up, it goes through a hole in the top plate, it gets right up into that attic. Or it could be what John described, like that plumbing pipe that's going through the fiberglass. And when that air leaves the house, it has to come back in, so it comes in through the bottom, which is, those are your leaks in your sills. Leaks in a window over here, maybe a leak in a hole in the foundation. That's wintertime. The summertime, it's the opposite. The air is colder inside, and it's warmer outside. You actually get the opposite effect. But in New England, what we're really concerned about is this wintertime, because that temperature difference, outside might be 30, inside 70, you get 40 degrees of temperature difference that's trying to equalize. That pressure, those temperature differences, farther apart they are, the greater the pressure. So you go to the summertime, it's 80, 72, not as much pressure, so we're not really as worried about it. But those forces still exist. And the other force is wind direction. So all those times when it's windy out, that's the other energy force that's going to create leakage on our house. So the wind blows on one side, you get positive pressure from the wind blowing, which wind goes over the top, you get negative pressure, which creates suction on the other side. And one of the concepts, when someone had asked about the house's breathing, and you're like, well, yeah, it does breathe a lot in the winter, which is why we see all of our problems in the winter. Summertime, it breathes less, but we still have moisture from the high relative humidity that can come in slowly and make you uncomfortable in your house and make your air conditioning work too hard. But what about all the times a year when we don't have a pressure difference and your windows are closed? That house isn't breathing anymore. It can't breathe because there's no pressure. There's no temperature difference. Let's say it's not windy out. There's no air movement. So the air inside your house, if you're all sealed up, it's not moving. So think of like a windy day, you open up one door, the other door on the other side of the house might slam shut. It's like, well, if it's not windy, that doesn't happen. That's the same pressure. So just something to think about when you think about the house ventilating on its own through breathing through holes. Well, yeah, it's not happening. So I did some air sealing on my shop last winter. This is actually air sealing when you think about it. That was a deadbolt that I didn't have on the door ever. I just put some tape over it. I had a window in the corner where the glass had broke. I think something came out of the shaper and just put a hole right through the glass. And so that thing was going like that for like 2 months. We're like, why is it so cold in the corner of the shop? And we just put blue tape over it. That's air sealing. Like that's as simple as it is. If you think about it, it's a hole, and we taped it. That tape actually fell off after a couple of weeks because it's not really the right tape to air seal. I've got a bunch of tapes over here at break time if people want to look at them. They can see them. So why are we doing this? This is all the stuff that John talked about. And for me, this is, as my approach as a builder, like everyone thinks, oh, you're all about energy efficiency. Like I don't build for energy efficiency. Like energy efficiency is literally a byproduct of the houses we build. And these are the things we're building for, which actually starts with air sealing because it's the most important thing we do. It's air quality. That filter that John showed you, that picture, a little backstory on that. There's a house in Charlestown. The couple moved in with their baby daughter, I think in February. They've been living off of Park Ave in Cranston in like a 1910 bungalow, probably rubble foundation, maybe somebody put concrete down there someday. Leaky as a sieve, probably very little insulation. If it was poor. She, over the last 12 years, started getting bad allergies, and especially in the springtime, to the point where she was losing days of work, uncomfortable for days on end, and then the Zyrtec came out. She started taking Zyrtec every single day. And that did great for the allergies, but who knows what else that did to your body when you're taking medicines like that. They moved into this house. She didn't know allergy season started. She had no idea. And she didn't take any Zyrtec for the first time in the last, however, since she started taking it. Stopped taking it completely. All because she was living in a completely airtight house with a ventilation system. So in the springtime, when you have like those, maybe you open all your windows and doors, it's like, oh, I love this air, but what happens when you do that? Like how many people go into their kitchen counter and they go like this, and it's all pollen. Well, they could live in that house and be really comfortable inside and no pollen. Like zero. It was all captured by that ERV. And you can see it, the picture John showed shows what was captured, which is a lot. Comfort's the other big one. Health is another huge one. We put in passive radon systems. Yeah, question.
Are those filters efficient enough to capture PM 2.5 particles?
That one, no. No, that filter, well, actually, I'm not sure. It's a MERV 14 filter. Yeah, I'm not an engineer. I'm an anecdotal engineer. So yeah, I don't have the facts on that level, but I do. It actually does capture, I think a MERV 14 filter captures the coronavirus particles. So however big those are. Yeah. Yeah, so we don't have radon problems in our house. And then reducing dust, pollen, mold, and then I think it does collect 2.5. Yeah, because that's probably why I put that in there. And then also a big one with the air leakage is long-term durability. Like those pictures John was showing of those mold in those attics. I do building science consulting, and I've seen situations like that where the roof sheathing's completely rotted out, and it was a 10-year-old house. I've seen that with windows. Same thing happened in the Charlestown package store. I don't know if anyone knows that beautiful liquor store in Charlestown. I forgot, it's maybe 10 years old, and they rebuilt the entire backside of that house, of that building, like all the way down to the foundation, just within the last year. And it was partially air leakage, but also bulk water. And better HVAC systems. So like that house that John was describing earlier, that house, the entire heating and cooling system is 2 mini split heads. That's it. So there's no expensive boiler or anything like that in there. And then lower energy bills, which is the last thing on the list, because it's a byproduct of doing all of this stuff. So how are we doing this? First thing before I ask of how are we doing this, it's like, well, these are really important questions. You've got a house you're gonna build. It's like, where is this air barrier gonna go? What needs to be sealed, and is it intentional? We need to start making it intentional. And the way we do that is we start with our plans. So like this is a house we're building right now in Charlestown, and it's not a box. Like a lot of people think, well, in order to do this, we got to build these little simple boxes. This is not a simple box. This is actually a pretty complicated house, and it could be way more complicated. I've seen them like that. So this is what we do in our plan set. So you look at that facade, but now you look, see this red line right here? That's our air barrier. And you can see we took that complicated geometry and we just created simple squares out of it inside. And that was intentional. One of the reasons it's intentional is, for example, like we've got these roof lines here, but we could spray foam this roof. Spray foam's really expensive. But instead, we actually we intentionally chose to make these flat ceilings here. By making those flat ceilings, we can use cellulose up there. It's like significantly less expensive. And it also allows us to have a ventilated roof, which means that we will have a much longer lasting, more durable roof. There's been a lot of case studies of roofs that have spray foam in them that end up having problems. And it's not the fault of the spray foam, it's the fault of all the other stuff going on in the house that wasn't taken into account when they did the spray foam. And then you can see on the other section here, this one does have a cathedral, and there is a ventilator. Actually, this doesn't show the top of it, but it's actually still going to be a ventilated roof. And then I think we can, actually the next photo I think shows it. Yeah, so then we get into our details, and you actually see like there's a little circle over, like this is kind of a complicated area. And where is that? Actually, that detail's on another page. But we actually have a circle around it so that when our crew's out there framing, they can see exactly what we're doing there. And here's another little detail of it. You can see our air barrier in this case is the sheathing, and then we're just carrying it over to the top, and we're gonna attach it to a membrane here. But the concept here is that we're doing this in the plan phase. And if someone's a simple spec house builder, like they're just doing 1,800 square foot or 2,400 square foot colonials, this is really easy to add in there. Like I could add it in less than an hour myself. Here's a picture, just do it like this, and you cut and paste it into the plans. But that comes from intention. Like we got to start thinking about this intentionally. So this is our process. We start with our air sealing with our sills. And the way we're doing that is we're covering the top of our foundations with a piece of Grace ice and water shield. And then in this case, we're caulking our sills down. So we're basically taking our sills, put a bead of caulk, and we're screwing our sills down through the caulk. One of the things we're doing, I don't know if you can see them, it's kind of far away, but we're using these little concrete screws. So like every 4 feet, we actually just screw the sill right into the foundation, and that squishes the caulk, and now you've got a sealed connection there. Because the foundations are going to be going like this. There's going to be, someone misses a piece of concrete, there's a little ridge in there, put a fat bead of caulk in there, screw it down, and you'll get it, like 95% of it. And one thing you'll notice here is we don't have sill seal. Sill seal, I don't even know why we've used it all these years. I think it's supposed to be an air seal. I think that was because it is kind of a crushable foam-like gasket. But over time, it's made out of plastics that over time, they actually dry out and end up rotting. I remodeled my house, it was 20 years old, and there were pieces of it, I took it out, it went like this, and it turned into a powder. So I'm not sure how long those are lasting. And then also capillary break, which is, moisture is a completely different subject, but when we put the Vicor over there, we're completely disconnecting the concrete from the framing, so that framing will never rot. Like, we could actually move right to spruce sills there, but I don't think you'd pass that, Jay, would you? No. I haven't asked that question yet. You'll get it from me one day. And then our next connection there, did I miss? Oh, no, maybe, actually, let me go. I think I got these out of order. Yeah, so our next connection is, so here's our Vicor down here. We know there's a gasket under here with a caulk. We're actually just caulking our plywood. So there's a little seam, bead of caulk on there. We just run a bead in there when we're framing our walls. It's really not that hard. I'm gonna go backwards now. And this is why we do it. You see all these spaces in here? Like, that's all air leakage. When you look at that stack effect picture with the air coming through the bottom, that's where it's coming. Like in a regular house, you have a piece of sill seal here, and then let's say these plates don't line up perfectly, the sheathing gets nailed on, that air is coming through those gaps and getting right through all these holes. And this is actually, we're very meticulous framers. Our company does really beautiful work. It still looks like that because you can't help the fact that your plywood, you're starting with that piece there. Now we're shimming between the plates because of the fact that concrete's not going to be perfect. It just isn't. And then even you take the lumber has little rounded edges, all that stuff adds up over the course of, even like that small house that we did that has such great energy savings, it was still 160 lineal feet of sill. And that's only a 1,800 square foot house. So that stuff adds up. And that's why we're getting it right here before you even get to all those holes.
Do you put that bead of sealant on both the outside and the inside, or just on?
Oh no, just on the outside.
Only on.
Because basically we're connecting from the Vicor to the sill, and then the sill to the sheathing.
So that sealant is sealing both the sheathing and the joint between them.
Yep. That's the continuity is not one membrane going all the way around. It's this piece connected perfectly to this piece, connected perfectly to this piece.
Using the zip system on that?
Oh, we are actually. Oh, this one we didn't. No, but you'll see pictures of that in here too. Yeah, here's just another picture of oh, that's what I did. I added the wrong slide in. So you can see it squeezing out right here. Like, so that bead of caulk is right here, and then it goes around the corner, and you can see it coming out.
But you're not putting a bead between that subfloor and the frame.
No, because we're getting it out the outside. Basically, if you look at the house as all these parts, it can get really complicated. Like, you have a roof with dormers, and you could have all these different lines. We're trying to find the easiest one. So we're taking all the complexity of the geometry of our structure, and we're finding the path of least resistance to create the smallest, or the simplest connections, which is, for us, is the sheathing. I should just say, if you want to build an airtight house, really cost effective, just use plywood or zip sheathing, and just use your sheathing as the air barrier. And one of the benefits to that is you're not adding a lot of cost, because the sheathing is your structural sheathing, it's the nail base for your siding, and now it's your air barrier too. So you get 3 things out of one product. And then here's our zip tape is connecting those two. And this is another product I have right up here, if you want to look at it later. It's an acrylic tape from Europe that we've been using these acrylic tapes for, gosh, over 10 years. They're not quite readily available in the US, but I mean, you can buy them online and the companies are set up so you literally get it the next day. If I order it by 10 a.m., it's UPS drops it off the next day. And this is an acrylic tape that's designed to stick to concrete without a primer. So instead of going through all that caulking, you can buy this tape. It's about 80 cents a lineal foot. It's the similar technology to what's in a lot of people I'm sure have seen the 3M all-weather flashing tape. It's the same thing. It's an acrylic adhesive, pressure sensitive. And what we do is we'll go around and we'll grind the top of the foundation a little bit. You can see it's a little bit of a grinder mark there just to take all these ridges off. And we're meticulous, so we're doing that anyways just to make it easier to shim the house later. It takes somebody about an hour to go around and just clean off the top of the foundation. We just hit that couple inches right there. And we can, if we do this one piece of tape, that actually takes away all the caulking. And on this house, we just had a helper do it. It took him maybe an hour and a half and 80 cents a foot times 160 lineal feet. Yep.
So that tape is clear? It just goes on so you can't really see the tape?
No, it's gray, so it kind of blends into the foundation.
And it withstands weather like all the time?
Oh yeah, the acrylic tapes from Europe, they've put them through, I think they're at like 300-year life cycle testing. And it passes.
You know the brand on that tape?
Sega is the company.
What is it?
Sega?
Sega.
Sega. Yep. Yeah, it's all up here. So afterwards you can get everything I'm talking about. We've got, well, not everything, most all of it. We have it right up here.
That's a good question. Is that,
Yeah.
So you're saying that's instead of the caulking?
Instead of the caulking.
Instead of the caulking.
Yeah. So for years we did the caulking, and then we discovered this tape.
I got you.
And because for years we had to, in order to use acrylic tapes on concretes or other types of surfaces like that, you'd have to use a primer. So that primer was a pain in the neck. It adds more labor, more cost, and it was how should I put it? I don't like those the caulks and the wet flashings and things like that, because one of the issues with a job site, well, I should say, they test all that stuff in a lab, and they've got all these beautiful conditions, and then you go to the job site, and what is it? It's cold, it's wet, it's dirty, it's dusty, it's oily, it's too hot, and you add all that stuff up. And guess what? A lot of those things don't like. They don't like the dust. They don't like the heat. Oh, it's too cold. I can't use it. Oh, it's too wet. I can't use it. Oh, it's too hot. I can't use it. You know, like just try putting ice and water on the roof when it's 95 degrees out. Yeah, I've lost a whole roll. It was like literally we rolled it up and kicked it around at lunchtime. But this tape actually solves all those because it's acrylic, so you can actually stick it to moist surfaces. And as far as the dust goes, I mean, even with a zip sheathing or any kind of tape sheathing, yeah, you got to clean it off a little bit. Like ask your lumberyard to, when they drop off the sheathing, to put some clubs on the ground or throw a pallet and stick a sign next to it. So when they drop it off, they don't just dump it in the dirt. Oh.
Looks like somebody ground the top of that foundation.
Yeah, we do that on all of ours. We
Just to get rid of
it gets rid of the ridges.
forms.
Yeah, it gets rid of those ridges from the forms, and we also do it because the concrete always is bellied a little bit at the edge, and it makes trimming the house a lot easier. So it's not about, for us, it's not about energy efficiency. It's about or air sealing. It's really about, we're trying to frame this house, and we don't want our plates to be like this because of one little ridge, because then you're fighting that the rest of the way. Yeah, but if you're there with a grinder anyways, just go that way. So it doesn't really add, for us, it doesn't add any time. And then once we get that connection at the sill, it's just tape your sheathing. I mean, this is just a zip sheathing. That's the passive house that's around the corner up here. We moved from zip to CDX for a while because not really happy with how zip swells. We were having issues with the nails. We were just having issues with it. So we went to CDX, but then now the quality of CDX we're getting isn't as good as it used to be. So we're back to zip sheathing. But it doesn't really matter. It's just that sheathing with tape will get a really tight wall assembly.
So you'll go over that with tieback then? For your
Yeah, we don't use tieback, but we go over everything with a WRB. Yeah.
So the adhesive in these tape products will last the lifetime of this building?
Oh, absolutely.
Really?
Yep, I believe it. Yeah. Yeah, when I've seen I haven't been to the Sega factory, but the people I share a lot of information with, they've actually been to the factory. They've seen the analysis. They've seen what they've put them through. And there's a couple people I know. There's a guy in Vermont I know that he's done a tape study on his own where he just took these tapes followed the manufacturer's specifications and taped all this stuff up. They've been sitting in his backyard for like 7 years. Like even like the zip sheathing, as an architect that I did that passive house with, he taped up 2 pieces of zip, just little squares, taped them together, stuck it on his wood pile in his backyard 4 years ago. You still can't take that tape off. Yeah, it's real. Just a quick little detail, like when we're going around these corners, like I showed you before how we had that caulk going this way, but when you wrap the tape around, you get that little square. So we'll do that. But that's what, if you're trying to get to like passive house level of air sealing, you can really get into the little holes. But and so then we get to our top plates. This is one of our methods for getting over the top plate. Is here's our sheathing coming up. Well, actually, in this case, this is a passive house, so this is 2 ways of doing it here. Like we could tape the sheathing to the top plate and then tape our next connection to the top plate, or you can just run a piece of tape over the top. And in this case, we're connecting now from our wall to our ceiling, so we're gonna run a piece of plywood over the top there. And so, like some of those plywood pieces, like when we're framing our house, you get all those rips coming out of windows and stuff. We just save them all and then we just rip them up into whatever width we need, and we'll use those in that place. And now we're going to connect from our wall to our ceiling, and this is one example we have. So this is a cathedral ceiling. So what we did is on the top of the wall, we added as a fabric that we use up here. We just ripped a little piece of it, then we taped it to the top of the wall before we dropped our trusses down. And I've got some of that stuff up here. So this is actually a material. It's actually what's called a smart vapor retarder, and it'll actually create an airtight envelope, but also it does allow moisture to pass through it, so it helps manage not having humidity problems or moisture problems. It's like for years we used poly on walls. This is the equivalent of putting poly up, but has the benefit of allowing moisture to transfer through it. We have a top plate. Oh, there we go. Just a little example of, this is another house. That little flap was put on the side here, and then we connected it across the top. And then what we did, we just changed our strapping from furring strips to 2x4s. And the only additional, what's that?
Why?
Oh, this is why. See all the wires? We've got wires to run through here.
Wires are all running underneath.
So everything,
So you're not drilling holes.
yes, it basically eliminates all of the holes that we've got to run through it. In this case, our electrician did have to run a couple holes, so there was some reason he had to do it, but there were only a couple of spots, and we just taped them. But that gives us a channel to run all of our wires through. You could actually, because it's 1.5 inches back, you could take a wire and jump over the top of the 2x4 in between the trusses if you had to go through that way. You can't do that with furring strips. We have done it with furring strips, and you end up putting a metal plate above it, and just adds more work. And this actually gives them a lot more room to do their job. In this case, we're using like these little metal brackets here are for those little slim LED lights. Yeah, is anyone using can lights anymore? Yeah, they're cheaper and easier. It's not too often you get that option in construction. So if anyone's still using can lights, look up the little slim LED ones. It's a much better light too. So this is another detail. I have a couple pictures of it, but they're not really good pictures, so I just wanted to show you here. So this is a house in Charlestown we're building. This is our double stud wall assembly, but if you're not worried about, this isn't really about insulation, so ignore that second wall. So here's our framed wall coming up, regular 2x6 exterior wall. Here's our sheathing coming up. And what we did is we took, we're doing a regular stick frame roof. Instead of putting collar ties going in, we went right over the ceiling with 2x6 ceiling joists. And then that allowed us to take the plywood and came up, and then we went plywooded right over the top of the ceiling. And then taped that outside corner. So now we've got a sealed lid on the building. And then we also have a cavity here that we can run HVAC. We can run all of our electrical in there. We can run plumbing vents in there without having to go through that air barrier. And that's a 2x6. Like we could make that a 2x10 if we wanted. You could create whatever space that you want.
Now, is that an unfinished attic?
Yes. Yep. So on top of this, 24 inches of cellulose. So in this case, we wanted to, we're building for higher levels of efficiency, so we made that 2 feet of cellulose.
What if you have mechanicals in your attic?
You don't put mechanicals in your attic anymore. You really shouldn't. We never should have put them in there.
What about a FEMA house? Like, do you have to keep the mechanicals out of the basement?
Well,
We have, unfortunately, a lot of times where we have no place other than the attic to put mechanicals.
yeah, that comes down to a design. That comes down to design. So like in our case, like if we're working with an architect, we like to start before we get too far in the design, and you have to figure out where they're going to go. And it needs to be integrated into the design, not design the house with all the beautiful spaces and then make the mechanicals an afterthought, and then they get stuck in the attic.
On a house I worked with Steve on, we ended up doing cathedral ceilings with
Yeah.
blown-in cellulose, scissors trusses. It was kind of
Yeah.
designed early on, and then we created a little spot up in
Yeah.
the attic that was
Yeah.
underneath the
Yeah.
insulated volume, so that ductwork could
Yeah.
run up on the second floor, but still achieve that.
Yeah.
Like, you know, I know
Ceiling.
what I'm saying. Sometimes it's like in these small
Yeah.
CRC footprints with FEMA.
Yeah, you have to do that.
sections of all these things.
Yeah.
It's not that we don't think it through, like that is the only
Yeah.
place. So-
Yeah, and that's where it's like someone like me that comes in, and that's how I was able to work with Kyle on that. And but like in this case right here, like this 2x6 ceiling joist, we have a house we're designing where that joist, that plywood's coming across the top. The house is like 24 feet wide. We're gonna leave a 6-foot channel in the middle with no plywood, and we're gonna frame a couple of walls and then frame a little roof over that and plywood up and over, and we're gonna stick the air handler in there, and then the cellulose just goes over and just dumps over.
So you can isolate
Yeah.
this section from the mechanicals. I was gonna say,
Yeah.
otherwise the barrier would be running up.
Yeah. Otherwise you're spray foaming your roof, which adds a lot of costs. You're adding petrochemicals to your house, and then you've got to use intumescent paint over it. Moisture collects up there. I know in multiple houses with the intumescent paint where the ceiling's just covered in mold now. Yeah.
I like what you're saying, so you can still create place, I don't mean, like you're creating a pocket inside the
Yeah.
attic space for your mechanicals, but doing it
Yeah,
in
exactly.
a way like where it's well off.
Yeah, so it's all about integrating it. And that's why I was mentioning before, like if we integrate this in the design process, costs go way down. Especially if they're integrated in a way that's cost effective. And you don't just, oh, we'll just spray foam it because that's going to make it easier. Well, you just added, depending on the house, you could have added 10 grand to the cost. Or a small house, or if it's a large house, it could be a $20,000 closed cell spray foam roof. So, and this one over here is the same house, but we have a cathedral detail. Sheathing came up, and you can see here we've got a little flap of Intello. We've got a little detail there showing it's going to flop over and go up the ceiling.
Is that cellulose insulation?
Yeah, we use all cellulose. Yep.
Fiberglass?
No, it's all cellulose.
How about rock wool?
We'll use rock wool sometimes. Yeah, we do use that insulation. I like cellulose just for, we're one of our focuses is sustainability. So when you start analyzing carbon footprints and materials, the cellulose is just way better for the environment. Yeah,
Will these slides be in our post email?
I think so. I hope so. Yeah, if you want them, just email me. Yeah. Yeah, actually, did I bring them? I think I've got cards, so I can leave as well. So I didn't have good pictures of it, but this is that ceiling. So here's our 2x6s. We ran our furring strips all the way across. So that cavity's there for whatever needs to happen in there. And then the nice part about it too is now we got that OSB. This is just $12 a sheet OSB, by the way. It wasn't anything expensive. And one of the benefits of this is when we framed that roof, they framed that roof without a ladder. They just basically were standing on top of that floor system now there, framing the roof. So safety, like, do we put that cost in the spreadsheet? Like we eliminated that risk? Like, do you think Beacon will give me a discount on my workers' comp for that? Probably not. And then when the cellulose guy was up there, like they were able to he basically stood up there and did his job. Like he didn't have to crawl around and dance around on furring strips, afraid that he's gonna go through the sheetrock or something. And the other thing you can see here too, it's a little hard to see, but there's our tape is right here. On the gable end, we need to tie that gable end just structurally. So on the gable end, we left that sheathing off. We pre-taped that corner. You can see the little piece of tape you can see here where we had to put that tape on the seam before that plywood went down. So there are a few sequencing things that have to be thought through. A couple more examples of the ceiling lid. This is a house with trusses. And what we did is we actually just plywooded the bottom of the trusses. This house, this house right here, the trusses went up first, and then we just used OSB and taped the seams, and then framed our walls. And at first, it was a contractor I subbed the framing out to, and they were like, "Oh, this is gonna be a pain in the neck. It's gonna be so expensive." When he was done, that's how he does it now, because it was so easy. The only person that didn't like this was the electrician, because they had to go climb in the attic instead of just running everything through the furring strips. But they complain about everything, so. What's that?
Then they have to put holes through that ceiling to get the wire?
Yeah, but then you go up in the attic and you spray foam the holes or tape them or something like that. Yeah, and like they make, like for example, there's companies that make these little pre-made covers that can go over can lights if you're using those.
So you applying your board directly to the plywood?
Yeah, sheetrock goes right to the plywood, so they don't have to wonder where the nailers are. It reduced. We had no when they went and framed the interior walls, the partitions. They just cut everything a 1/4 inch short, stood up the walls wherever they needed to, and shot them in. No blocking. Parallel walls didn't need any blocking. The gable ends didn't need any blocking. They just stood walls up, nailed them in. That was so fast. And same insulator was up there. He didn't have to worry about going through the ceiling anywhere. Made it really easy for him too. What's that? Yeah, that never. Not in this house. Doesn't go through. And then this one we actually did a 2x6 chase. Put the plywood up there, and then when we went to set the trusses, we're standing on a ceiling setting trusses. It's like raising a roof on the ground. Last area, so that basically gets us our box, our shell. And the last thing I just want to talk about quickly was penetrations. These generally aren't huge points for air leakage. Like if you just stopped the presentation here, unless you're a complete moron who didn't care, you would be well below 3 air changes per hour. Like I guarantee it. If you kept those connections around corners and followed that system, easy peasy. The issue with penetrations is that as you make these houses tighter, those pressures don't change. Like those physical pressures that are coming from Mother Nature are constant, and you can't stop them. And as the holes get smaller, those pressures get concentrated on smaller and smaller places. And where are those small places that are left? It's penetrations. So if you don't detail these properly, when you have those wind rain events, the pressure is going to be 100% concentrated on these spots. And a good example of this, I don't have pictures of, but I have a good friend that has a timber frame house, SIPS panels, right on Ministerial Road, 5 minutes from here. He has to replace the soffits on the north side of the house at his bathroom every 5 to 8 years. And it's because it's a SIPS panel house. The SIPS wall to roof connection was not air sealed properly. The bathroom's there, moisture in the bathroom, that stack effect in the wintertime, 100% of the leakage on that entire roof is probably in a couple of feet right there. So all winter long, the air is going through there, dropping all that warm, moist air is going out that crack, and it hits the trim. Collects moisture, rots out. Rinse and repeat. And it's because of the concentration. And I remember a couple of architects, almost like 10 or 15 years ago, when they switched to spray foam on really high-end houses, icicles coming out of soffits was constant. And it's because the spray foam does air seal, but if you have a double top plate, there's no spray foam in there. All the foam's in the cavity, but all the connections are ignored. So all of that air leakage that was spread out over the entire square footage of the shell is now concentrated in these lineal points. Top and bottom plate, top plate. 2-story house, greater pressure difference, greater concentration of air leakage, and it's all going out these single holes. So that's why we look at penetrations. Like electrical boxes, I've got all this stuff up here. We're using these boxes. They're made. I have to buy these online, so I'll just show people. They're not hard to get, but you can't just go to the supply house. But basically it's just cutting a square hole, stick a box in there and tape it. So that's 100% airtight. The other thing too is these won't rot out. I've replaced a lot of them over the years, the metal work boxes that go in and they rust out. So These don't have that problem. The other thing we do is we'll take, no, I don't have a picture of that, but we'll take a box like this and we'll screw in, let's take a little piece of conduit with a screw-in connector. This pipe just goes in the wall with a gasket. I've got a couple of samples up here, and there's actually like, you can do this. This is on the shelf just downstairs. I don't like these because they're really thick, and I don't even know how much this was, but it was a lot more money than this. And if you don't go online and buy gaskets, this is just a scrap of EPDM, which is not hard to get. Just go find someone doing a rubber roof and go to the dumpster the next day. And you just take a piece of that. I think I've got, yeah, that's this right here. I fold it in 4 and just made one cut in the middle. Do I have that here? I didn't bring my scissors. But you could just take a piece like this, you fold it in 4, and I just snipped that. Stuck it around a pipe, and now you've got a forever gasket. Tape it to your sheathing, and you'll be airtight forever. So that's our electrical outlets. And these actually also light fixtures too. So if we've got like a surface mounted light fixture, it's same thing.
Are you able to get your electricians to do that for you?
No, we actually put into our budgets. So on an 1,800 square foot house, I put in a budget 8 hours for one of us to go over there. And to be perfectly honest, if you're doing anything with wood siding, the electrician's not locating those boxes and cutting the holes, because you're lining up your siding with your light blocks and stuff. So we're doing that layout anyways. So if it's a matter of just drilling a hole in the wall, it's like, hey, put it here. But my electrician does do that now. It doesn't bother. We'll actually drill the hole, put the gasket up, and sometimes we'll just take these and we'll make them up and just stick them in there, and then he takes it from there. And sometimes we'll just put the gasket in there and they know what to do. So there is, again, it's new stuff, you got to learn it. And part of it too is we're all professionals, right? Isn't that part of being a professional? Continuing education, learning, getting better. I hope my doctor's doing it that way. I hope our builders are doing it that way too. So this is what we do for hose bibs. So what we do is that's actually a piece of pipe. We try to run those into the back of like a vanity or a kitchen sink or something. And then we take there's our hose bib right there. We'll just attach that to a piece of PEX, sticks it through, makes our connections in here, and then we just squirt a little foam inside that pipe. So when that frost-free valve fails, because they all do, you can just go inside the vanity, cut it out, pull it out, put a new one in. That's a slab-on-grade house. We didn't have a choice, but you could do the same thing in the basement. So that's how we do our hose bib.
Frost-free though, right?
Yeah, that's frost-free. Yep.
Does it have like a foot long on those things?
Well, if it goes in the back of a cabinet, or if it comes in through a basement, goes in the back of a cabinet. You can get those with shorter ones too. I think they make them down to 8-inch maybe. But also, we're building double stud walls, so our walls are already 12 inches thick.
Oh,
But if you're in a basement, yeah, it's just right through the rim joist. Yep. HVAC penetrations. This is the big one. I'm trying to think. This is how we do it. This is how we used to do it. So we've got up here, these are all of our electrical connections, which are we basically take that same pipe like this, and then you take your AC disconnect, take the knockout out, and you stick it into the back of there. After they wire it, you just put a little foam or caulk in there, and now you're airtight. Because typically in a typical house, they're just drilling a hole through there and stuffing stuff through, and there's no air sealing. And if there is air sealing, it might be someone with a big blob of silicone going around it, or electrician's putty. And first of all, it's not a really good seal, and second of all, it dries out, falls off, and in a couple of years, you're not airtight anymore. And you can see, like, this is where they're coming through on the inside, where they're going through the pipes on the inside. Everything's foamed. And this is an example of what it looks like on the outside. We used to use a piece of conduit that already had a bend in it, so that when the water, like these, when it's raining out, these get covered in water. This way, the water can't follow the pipe into the house. But actually, what we're using now, which I really like, these are right downstairs. It's just an HVAC line set flashing kit. So you can actually get a really big hole in here. And I have yet to meet an HVAC contractor that doesn't really like this. It makes it really easy for them to make their bends and everything. And what we do is we just either put a bead of caulk on the back, put it in or just tape it to the sheathing. And then you just cut your siding around it. And at first I thought these were kind of big and bulky and ugly, but when you look at the end product and what's going on there, it's like, this isn't a fashion show. There's a reason. We're hiding all this stuff for a reason. So, and like, this is a good example. I put this in here at the last minute. Like, this is a typical line set. This is a retrofit, but what do you think's going on back there? And the reason I was here was because we had just finished this basement remodel, and they had water in their basement. They're like, oh, you must have done something wrong. And the HVAC contractor that came like 3 months later when they decided to add air conditioning, that's what it was. So this was basically just a hole through the siding with no flashing whatsoever, and the water was just going right through there and in there. Yeah, it was pretty ugly. So here's another example. This is our ERV penetration. So this is an inlet or an outlet for an ERV. This happens to be a house with exterior rigid foam. There's a couple reasons I put this in here is, in order to maintain air tightness, you also need to be thinking about water tightness as well. So like all those examples I showed you before was just to make it airtight, but we still want to keep that water off of our sheathing. So there's another layer, like when you get into we go over the zip sheathing with a WRB, and we integrate that with the flashing so water gets behind the siding, can drain out. This is a house with exterior rigid foam. This is one of the reasons why I don't like exterior rigid foam, and I really hope people start learning how to get by the new code that's asking for exterior rigid foam, because that's going to cause a lot of failures in the near term, and it's going to get a bad name because it's not the foam. It's really hard to do it, and the workmanship out there. Like, I don't want to. There's all levels of carpenters and types of building and price points, and we need all of them. Because not everybody can afford to hire the best builder. And even if we were all the best builders, one of them is going to be the worst if we actually had to line them all up. And this is really hard to do. It's a lot of attention to detail. So like we drilled our hole for the pipe. We have our air barrier there. That's our flashing for our air barrier with a gasket. But now we got our rigid foam on here. So now we got airtight at our sheathing layer, but now we got to make it watertight at the front layer, which is the face of the foam, or the WRB at the face of the foam. So now we got to do it all over again. So we just doubled all of the work on all of our penetrations by going with rigid foam. But it's watertight, it's airtight, but it was a lot of work and a pain in the neck. But that's what you end up having to do. But same principles though. You pick your air barrier, like where is it? It's a sheathing. If we want to get there as an industry, we got to stick with the sheathing. There's a lot of if you research air barriers, there's a lot of other ways to do it. For years, people were talking about airtight drywall. And it's like, well, don't hang a picture. Like, don't get angry and put your, it's like, there's a lot of reasons not to do it. And then there's all these different membranes you can put on, like the Tyvek and all, but you can see that's not. But we're already doing the sheathing. Like that product's already there. Like if you go around, even the cheapest spec houses, they're using zip sheathing. So everyone's worried about cost. Like they're already buying the stuff and taping it. Just do that thing at the bottom and do that thing at the top, and you'll pass code. And if you care about long-term durability, then well, do the penetrations too. We'll get to that later, I guess. But and those penetration issues, those aren't about like if you don't do this, the house is going to fall apart. It's more about long-term durability. If you're buying a spec house, like you're not buying it for the long-term durability. That's just a fact. And here's actual electrical panel detail. Same thing. We've got gasket, just a bigger piece of conduit there, and then that just screws into the back of the meter socket, and then a little bit of spray foam in the wire. You kind of see it's the same thing over and over again, more or less. Conduit, gasket, a little bit of spray foam or caulk. And then these are our blower door numbers. So just these numbers are all just sheathing and that little bit of tape or caulk at the bottom, and then however we connect it to the ceiling. And so this is an 1,800 square foot house. This was 0.13 air changes per hour when we did the math. And that was just zip sheathing, caulking under the sills, and then that little detail at the ceiling. That was it. Like there's the added cost there was the caulk at the bottom and whatever we did at the top, because we would have used the zip sheathing anyways. Yeah, this one's at 82, so that's probably around point. Yeah, I think that one's around 0.22, and this one we're at 49. I'm not even sure which house that was, but yeah, they're all really, really low, well below. I mean, if we're trying to get to 3, like that simple system got us to here. So if we're trying to get below 3, it's really, I'm just trying to show you guys, it's not a big leap. And people that are afraid, this was the first passive house I did, and that everyone, when we were first doing passive house 10, 12 years ago, we're all worried about the air barrier. Everyone's like, how are we gonna get that house that tight? And everyone was really, really afraid of that, because all of the work in passive house happens with the modeling. So you have to design the house, put all the details in, you send it to FIAS, and they run it through their energy modeling, and they let you know whether it passes or.
What's the ACH 50 on the passive?
Oh, 0.6.
0.6?
Yeah. So everyone's really afraid to try to hit that number. And all the work that gets done in the modeling phase that gets you to pass, that's all prescriptive stuff. So once it passes, now you just follow, it's like a Lego set, just follow the instructions and you get there. The only one that we could screw up was this. And so as the builder, we're really nervous. And I had no idea what was gonna happen, and we just followed, all right, we're gonna use our zip sheathing, we're gonna tape this, we're gonna do this caulk detail. And we were at 35. So I think obviously it was a lot of wasted worry and energy there, so.
Steve, can I just
Yeah.
interrupt 1 second? So as someone who does a lot of blower doors, right? PPI certified, so you do a lot. You ever see a 35 before? No.
Not even on the top.
No, that's the lowest.
Yeah, not even on a duct.
That's the lowest number that I've ever seen on a blower door. So
Yeah, I had to buy the E-ring. And actually, the other interesting thing too is when we got that number, the slab wasn't even poured. So that was just foundation to walls. Like no vapor barrier, no slab. So. And there's one other thing in here I'm going to show you. So I just wanted to go through. So this is I do blower door tests in our community as well. And just wanted to show you this, just an example of the way a normal house is being built where they're not thinking about this. So I could get this house to pass. And this isn't their bulkhead, but this is exactly what it looked like. So I go down to the basement. This is the bulkhead. Like, is it code to put a door at the bottom and make it airtight? I don't know, is it?
I don't think it's a wire.
No, it's not code. It should be. That's a Bilco door bulkhead. And unfinished basement, fiberglass in the ceiling, fiberglass in the rim joist. Sure, no caulk under the sills, I'm sure. I doubt they know what Seagood tape is. So typical sill detail, shimmed and all that stuff with fiberglass. Got that open bulkhead. And then I also did the duct test on the house, which failed. And like that's how the ducts were installed. That's all the ducts are in the floor. Like that's code. Shouldn't be code, but that's code. That's why it failed the duct test too. So I could actually put my hand through there. Like if someone was in the basement, I could have had a full conversation with them. So that was every register in the floor. And this is an interesting one too. Sorry about the terrible photo. I was so excited when I took it. I was shaking. So the whole is a ranch house, so it's a lot of surface area lineally. And every single light fixture in the house was one of those slim line LEDs. So all they did was they just popped holes wherever they wanted to. And you can kind of see it up here. These are the wires that they left up there. This is our furring right here. Typical assembly, the trusses, furring, and there's our fiberglass. Like by code, the insulation is supposed to be in contact with the air barrier by code. But for some reason, it's okay to put fiberglass over furring strips between trusses and the ceiling. That's code. But once you do this with the electricians, doesn't care about the insulation code. But this is what it ended up with. And every single light fixture was like this. And this one wasn't installed yet for some reason. And then this is what the attic looked like. Yeah. Yeah, they got their CO, and I know they didn't fix this. So that's what the insulation looks like up there. So you look at what's going down below, and now you got all these holes in the ceiling. There's probably 80 light fixtures going through that ceiling. And then see, how do I get this to play? So this is what it looked like. That was that one hole. That's with the blower door running. Yeah. Yeah, it was crazy. Yeah, that was the number they were at. Yeah.
2,200.
Yeah, 2254. What's ironic though is that actually would have passed code a year and a half ago. So that it was like 5 point something, and it was close. Yeah, I could have been nice and just put a piece of tape on something and passed them, but I was honestly I was pissed off because like the reason I was pissed off is that's all code. And I was like, well, if you can't make that code, then we're gonna make you follow this code. And I'm not sure what he did, and I got to go back and retest it. But I told him just put a door at the bulkhead. You should do it anyways. Just do it for security reasons. You know? So that's just an example. That's what we normally are seeing. And if you look at what I presented to you about what we did, like how much harder would it have been to do that with this? It wouldn't have been that hard. All they would have added like on that house there, just before they put the furring strips up, put up that Intello. It probably would have cost him, I don't know, maybe $2,000. And don't even use Intello. He could use Tyvek there. He could have just taken a roll of Tyvek and taped it across the ceiling, and it would have done the same thing. And then do a door at the basement, which you should do that anyways. Yeah, that's the end of any questions?
Do you have any attic access interior, or is it like exterior?
No, we do interior. Yeah, we just have a detail for for a hatch. Yeah, but actually, well, one of the things we do with design, and a lot of this for us comes down to design, and we through design, like design and engineering are kind of the same thing. We engineer out all the stupid stuff. Like, don't store stuff in your attic. Like, if you need storage, part of our details are to condition our basements properly. So if you want to store stuff that you actually want to keep, and you actually want it for future use, like put it in a basement we make the basement's part of our conditioned envelope, put it down there. Or if you have the space in your house, like carve out some space. Like in some of our houses, like we have like the kids' bedrooms, and the way the geometry works, you end up with a walk-in closet. Like how many kids need a walk-in closet? So what we do is we make it a regular 2-foot deep closet. We put a bifold door at the back, and now you got a 3 by 6 foot storage space that you just robbed from your kids, you know? So like we engineer it into the space. And so our attic access holes are just whatever code is. And then we actually take extra EPS from our basement slabs, and we stack it up and get it relatively tight. And then we have a cover on there with a gasket that just gets put up there with some a clasp or something to basically pinch the gasket. Yep. Any other questions? Everyone's in awe. No? Oh, good.
Do you find that with your subs, you have to bring them all in on this, so they're conscious of what you're trying to achieve? That they're not making any penetrations?
Partly, at first it was a little bit of that. Well, there's a couple things here. One is we use the same subs, because we're a really high quality company. So, and actually any company should do this. Like use the same sub over and over and build it into your estimate, because that builds that relationship. And they're allowed to do their job faster. Like everything, communication errors, like everything works better if you use the same subs. But one of the things we've always focused on is we design and engineer details that try to keep it as business as usual. Like I've been doing this for 25 years, and the first 15 plus, I didn't know any of this stuff. So, and we're trying, like when you go into our houses, they don't look anything different from a normal house. Yeah, I mean, Jay, you can attest to that. There's nothing weird going on. Like my electrician actually enjoys working on our project more than any other projects, because the level of organization we bring to these details, we actually bring it to all the other stuff too, which makes their job easier. But if you design details that are simple, then yeah, anyone can do it. Yeah. And honestly, most of the subs that are working on basic spec houses, I think you've been your installation company. Like, do you think your crew in the field would rather be on top of that plywood floor laying insulation or dancing around in? Well, yeah. Basically, we apply that concept to the construction process. Yeah. And there's a little bit more oversight. But then the other variable too is if you make it easy, they don't care. Because most subcontractors want to show up and do the job that they like doing. And if you, as an architect or a designer or as an industry, create codes that make them do gymnastics, like they're not going to be happy. And they're not going to enjoy the work, and they're going to do a crappy job. Because guess what? I act as perfectionist as I am. I'm the same way because I'm a human being. If I have to show up and do stupid stuff, I'm going to be miserable. So.